Okay, percent multiplier. If you got 8% interest compounded monthly, the monthly interest, it's paid every 0.12. So your paid interest monthly, then the 12% that you're getting per year, you're getting 0.01 monthly. So your percent multiplier, I'm not exactly my multiplier is going to be 1.01 because I'm taking the percentage and I'm adding it to 100% of what I started with. Okay, so multiplier wise, 8% compounded quarterly, well, I'm taking 0.08 divided by 4 because the number of quarters, that's equal to 0.02. So my multiplier is 1.02, but that's, keeping in mind that's a quarterly thing, that's a monthly thing. And here 9% compounded continuously, well, our multiplier is just E, because continuously means we're using E as our multiplier. Okay, the exponent's going to be something different. The equation for each, we're investing $1,000, 1.01 to the, now a certain number of years we don't know, but the key thing is we don't want years, we want months. So whatever if you invest for 20 years, it's 20 times 12 because you want this is a monthly multiplier. So you're going to have to multiply by 240, 12 years or 12 months worth of 20 years or whatever, the other way around. It's your equation here. Again, 1,000 times 1.02 to the 4x, because it's how many quarters are there in 20 years? It'd be 80 quarters that we do here. And this one here is PERT, P-E to the R-T, E to the rate, which is 9%, 0.09er, times the number of years. And so that would just be the X. It looks a lot different. You need to kind of recognize this as compounded continuously and how it works differently. And the value after 15 years, you would just plug 15 into each of those, and I did the hard part for you there. So I'll let you come up with those numbers. But then here, find the amount of time it'll take each option to yield $1 million. I'm going to do 2 of these for you. I'm going to say 1 million. There it is, enough zeros. Equals 1,000 times 1.02 to the 4x power. Well, it's going to require some logarithms or a boatload of guess and check. Divide by 1,000, divide by 1,000. We're going to cancel these zeros and those zeros. So we still have 1,000. And it's 1,000 equals 1.02 to the 4x. Let me write that out. The only way you can get that guy out of there is to take a log of both sides, or we can go back to what we did up here and say I'm going to take the log of this divided by the log of that, okay? And it's the same thing. So that's why we did this just before, okay? If we do the same thing here, log of this divided by the log of that, now the x goes around in front. We'll go through the process. Log here, log there. That 4x goes around in front. So I'm going to write this out as, so we need some space. So write it out. Log of 1,000 equals 4x times the log of 1.02. Okay, keep in mind when you take a log of something to a power, that power goes around in front. This is why you divide by the log of the base, because you're getting x by itself, and technically you can do a little bit more than that. So, but I'm going to leave it at that, because now you can kind of recognize the way we had it set up. You had your base here, you had your solution over there, you divide by the log of the base, there it is. Plug that into your calculator as is, log of 1,000, which by the way is 3 if you were to calculate that by itself, divided by the log of 1.02. Crank that out. Now that ends up being 348.83 equals 4x. Okay, how long is it going to take $1,000 to turn into $1 million? It's a long time, but you're asking an awful lot too. You divide by 4, divide your answer by 4, and you end up with only a short 87 years. But that's $1 million, people. That's not bad. If you can hold out to go to college, you're going to go to a really nice school at that point. You're going to be 87 years old though, if you invested when you were 0. But that's okay. Planning is a good thing. When you look at option 3, you're dealing with E, a base of E, okay? Now, when you do a base of E and you're doing the same $1 million growth deal, you want to do the natural log, because the natural log of E is going to, oops, 1,000, sorry. Talking and teaching, it's hard. Okay. So we're going to divide by 1,000 first, same way we kind of started the other one, divide by 1,000. Okay, I'm going to move this over here and get a little more space. So I now have 1,000 equals e to the 0.09x. The natural log is what you're going to want to do, because the natural log of e is equal to 1. So you end up with a natural log of 1,000, oh my goodness, 0.09x. When you do the natural log, and that goes around in front, the natural log of e is 1. And so you technically have a 1, and then this moves around in front of the 1. So it's this times 1. So the nice thing about this, it's actually easier, I think, to solve for a exponential growth because of the nature of how this all works. Your x is simply now just the natural log of 1,000, which is not a nice, clean, and ordinary 3. It's the natural log of 1,000 divided by 0.09er. You hit enter there. It's 76 years, 76.753 years. And that is, I'll let you do this one. Good luck with that. I think you'll be fine.